This is electrical and stuff here. We gotta, did you find them bolts under that rotor?
Yeah.
That's what we're trying to do, get that pan off there. But, we're gonna run through a little something here today, give you some stuff. Who recognizes this? You ever seen that before?
I can't.
Can you tell what it is, looking at it?
Is that gonna be,
Is that down there?
This is a really amazing electric motor. It can spin 10,000 RPM, and within a quarter of a turn, it can stop and spin back the other way just as fast.
This is it.
That's pretty impressive, isn't it?
Which one is it?
If you, it's got over 40 parts here. If you take one of the parts out, it won't work.
Golly.
What car is it? Though, like whatever it's on this car or something.
That is that little motor that spins the tail on a bacteria. See that little whip-like tail on the back of a bacteria that moves him around? That's the diagram of the motor that drives that. You got that?
Mm-hmm.
All right. I just like to start this off with that. It's just amazing to me that it's that tiny and it works that well, you know. You got these little bitty parts here. All of the stuff that you see in these that we've been using for a long time, all the little electronic parts and resistors and transistors and that kind of thing. And you gotta recognize the fact that all these little parts makes this possible. And some of these parts you may recognize, some you may not, and all that kind of thing, but here's the various different resistors. And a lot of what we're gonna talk about today is gonna be that, plus some wiring schematic stuff. But what I'm gonna do is point you out how these little stripes on these resistors work. And so basically, here is another, I came up with this one over here. Big Billy ran over young George because Vicky grew weed, right? That's when I came over. I don't like the one that they came up with back in the 1940s, and I don't even tell people what it is. This one here says, bad beer rots our young guts, but vodka goes well, get some now. You know, there's another one that somebody came up with. But what you start out with is they give you your colors and the numbers. Black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, silver, none. Now this actually gets a little farther than that. But basically, if you remember those colors in order, and you remember they start with 0, and they count up to 9, you can basically wound up giving you, getting an idea of how much resistance the resistors got based on the colors. And I've actually got some resistors on a board right here that I have you actually figure those up, looking at the colors, and then you go back and measure them and see if you got it right, you know. And this is basically just some electrical stuff. This is resistorguide.com, where I got this right here. It's pretty good stuff. All right, this right here is your first digit. This is your second digit. This is your third one. And then, then you do your multiplier. Now this right here looks kind of complicated. And so what I do is I move on to here. First digit, second digit multiplier. And this right here would be just 2% or 5%. It's either going to be gold or silver typically. Most resistors just have 3 stripes. And so if your first digit was yellow, see, that would be 4. Second digit was purple, that would be 6. And your multiplier was going to be orange, that would be 46,000 ohms, right? See that? The number of zeros is what that third band gives you. But they all have got numbers there. So that's not anything, it's all that terribly complicated, but whenever you look at a resistor that's like that, little bitty teeny tiny resistors, I got on a lot of boards right now, I've actually got little numbers on them and stuff. And here's another one. This right here was something I got from Radio Shack a long time ago, but I put the picture of the resistor on it. Black, brown, red, orange, yellow, green, blue, violet, gray, white. Now who can remember those without that little memory bug over there, right? You notice that? Notice that the third one, the fourth band is the tolerance band, the third band is how many zeros. So that's your multiplier, always remember that. First letter, first number, second number, then your multiplier. So when you get the worksheet for those resistors, you'll know what to do. All right, abbreviations, amp, farad. What's farad? What farad is? Farad is the measurement of a capacitor. You got it? And so most of them are like microfarads and stuff like that, but Anyway. Alright, so I is current, P is power, R resistant, V volt, W watt, ohms, and then meg, kilo, milli, micro, nano, pico, you know, basically all these little symbols that you're gonna see. When you start seeing those, I want you to recognize what they are, right? Alright, now, whenever you're doing measurements on a particular sum, if you're measuring ohms on it, you want to start on the lowest scale where you can get a reading. You know why that is? Because you want the highest resolution reading you can get, right? Right? You got that? Don't you want a high resolution reading? Like if you're measuring a thing and you got it on 200,000 ohms, you're going to read continuity of like, you know, like it's straight shorted. But you're not going to know how many ohms it actually is. Well, what if it was 4 to 6 ohms? You wouldn't know if it was 4 to 6 ohms if you were measuring on a huge scale. So go down to your lowest scale that it'll read. If you can't get a reading on 200, on the 200 ohm scale, and notice this is the ohm scale, that's your DC volts, that's your AC volts, it's only got 750 and 200 on that. Amps is going to be right here. Now, one of the most important things that I can tell you guys, and I'm hammering on this all the time, is there's a reason I have these cheap little meters. You know, a lot of other programs will have them big old flute meters, got that $10 fuse in them and all that, but I ain't, you know, I don't like having to buy all them fuses. If you put that meter in that hole right there, this becomes a dead short. In other words, this meter becomes a jumper wire. You got that? If you ever hook that to the hot in the ground side of a battery with it hooked up like that, with that in that hole, it doesn't matter where this is. That's a dead short. Now when you put it over here on amps, you're going to be reading how much current's flowing through that meter. So it's always got to be wired in series when you got it in that hole. When you got it in this hole, you're going to be putting it in parallel, which means you can hook it up to the positive and negative on a battery, or you can hook it to the positive and negative on a bulb, or you can hook it to the ground and then hook it to the hot side and all that. But remember this, if you don't remember nothing else, when you put this in this hole right here, there's a dead short inside that meter, and it can't carry but about 10 amps. So if you actually put it on the positive and negative side of the battery, the meter becomes a load and you've lost your meter. This has already happened here this semester. Where's Dakota at today, you know?
Oh yeah, he said he's gonna be late if he comes, cause he doing stuff with his family.
All right, I get that. All right, 2,000 ohm scale right here, and basically you've gone up, you know, you're from 200 to 2,000. So if I was going to read a anti-lock brake sensor, let's say, that was going to have like 2,200 ohms of resistance, I couldn't use this scale, could I? Because it's more than 2,000. Or if it was going to be 1950, and there was a chance it might bump up over 2,000, I might still get nothing, right? So that's how you're going to go there. Now, this scale right here is 20,000 ohms. That one right there is going to read up to 20,000 ohms, but if I'm reading something that's 21,000 ohms, I ain't going to get nothing there, am I? So what I'm saying is you're going to go to the lowest range that you're going to read. And that's true on volts too, but most of the time we're going to be reading on 20 volt scale, right? All right, so see if I can get that thing to go. 200,000 ohm scale, that ain't rocket science, all right? 2,000 ohm scale is what, 2 million ohms. That's a heck of a lot, isn't it? One time, me and the boys got a kit that we bought for like $10 or $15, and it had all the little bits and pieces of one of these, and we built one, put it together from scratch. The only problem is this little chip that drives this display, they didn't tell you which way it went. And when we put it together, we had multiple decimal points and the numbers were in the wrong place, all that kind of stuff. All right, now let's look at wiring schematics here. This is a GM wiring schematic, the way that they have it on there. Now these are hot buttons up here, location and description. And look at this right here. You got your fuse block. Always your power is going to be coming in from the top. And you got to be able to trace this power. Like if you're working on something that's not working, like if you're trying to figure out, you know, well, such and such a component is not working. You got to be able to start here. Okay, whenever this happens, this power goes through here, and then when that happens, that's a little splice there. That's going to turn on my LED. It's going to go down here to the AC high pressure cutout switch. Your AC request signal. Let's say you plugged in your scan tool because your AC wasn't working. Let's say you went over there and you looked at your AC request signal, which meant my customer is basically wanting to turn on the air conditioner, and the vehicle control module, VCM on that particular one, or PCM, is basically gonna be looking for this signal right here, this power, to come all the way through here. Now, that's a current limiting resistor, and it's gonna be measured, making the measurement right there, that electronics in here is. Okay, so let's say that I wasn't getting an AC request signal. Like I say, so my scan tools, I've turned on the AC, but I'm not seeing an AC request signal. What do I do first?
Check the power supply.
Well, that's not a bad answer. Up here, the fuse might be a good place to look. It's a 25 amp fuse. But what I would also be wanting to know is, am I seeing my LED? What if I see my LED, but I still don't get a request signal? What's that telling me? See, because notice it, this right here, click mode dial, defrost, detent. So, all right, if that's burning, what does that mean?
It's getting power in there.
Yeah, or there's your AC push button switch, so you've got power at least making it that far. That makes sense? Okay, and so then I'm gonna go on down here, I'm gonna go to the high pressure cutout switch next, if it's easy to get to. And then I'm gonna check and see if I got power right there. If it's gonna carry a load, a meter is not a good thing to use. I've actually got a video on my YouTube channel saying why a meter in a test light aren't enough. And one time the Ranger developed a no start all on his own. And so I went out there with the test light, and we took the bed off the Ranger, and we turned it on, the fuel pump wouldn't run. And I unplugged the wires from the fuel pump, and I hooked my test light to a good ground that I knew was a good ground, and I checked it, and when we turned it on, the test light burned. And so I hooked the test light up between the ground feeding the pump and the, actually hooked it up right where the pump would be. And the test light came on. I said, well, I got power and ground here. So we pulled the pump out and put it on the bench and fired it up with the power supply, and it went wing. I said, well, the pump works. What's going on here? So then I got that headlight bulb that's in that glass cylinder or that plastic cylinder over there. And that headlamp bulb pulls about 5 or 6 amps. About a quarter of an ounce all you're pulling with a test light bulb. So we hooked that headlight bulb up, and it wouldn't come on. And it's pulling about the same thing the pump is going to pull. So the point is, if you're measuring the veracity of a ground or a power feed, and it's a load carrying circuit, like a fuel pump, you better be measuring it with something that will light up and pull as much of a load as your actual load does, or you're not going to get good results. And a lot of your schools will say, don't use anything but a voltmeter on these modern cars because DVOM is the only thing you're allowed to use. There's a guy that used to teach for Freightliner that came up here with his Dodge Caravan, and he was wanting me to check his power windows. And when I was checking him with a test light, I thought he was going to have a stroke. Because he'd been teaching, he's an instructor for Freightliner, and he'd been teaching, you'll burn the computers up. I've never burned up a computer in my life with a test light. You know what I mean? I'm sorry, I just hadn't. And if you go to some of this really high-end KC Vision training and all, every one of them will tell you to use a headlight bulb, or some of them will say put 6 tail light bulbs in a box and wire them all in parallel so you're pulling enough amps. And if you don't want to pull quite so many amps, take some of the bulbs out of the sockets. You put 6 sockets in a little project box and all that kind of stuff. But anyway, long and short of it is, so this is not going to be a high current circuit. This is actually just going to be nothing but a whisper of voltage that's going to be coming in here through this high pressure cutout switch. And I can check this with my meter. All right, so I check on the meter, I see voltage here. And then with this high pressure cutout switch, we have to countenance the possibility that we might have high pressure in there, right? Well, consider the fact that if you got a gauge on it, the pressure is not there. See, a low pressure cutout switch is actually looking for the same thing, but it's actually a ground signal. So if I don't see any power here, but I do see some here, I'm thinking there's a problem right there. I make a jumper there, I jump past that, and then if my AC comes on, I know my high pressure cutout switch is my problem. You see how we're tracking that? That's how you do it. Ain't real complicated and all that. So anytime you're going there, all right, now let's look at a different one here. I can get this to move. All right, now, look at this one right here. You might notice on these vehicle control modules, they've actually got these little things here, C1, C2, C3, and C4, blue, red, clear, and black. So all of the different connectors that go to that particular module on that particular truck, GM is really sweet about that. They make them different colors, and if you're looking at C1 and C3, see these connectors right here? Dark green, white is your wire color. What does that number right there mean? Anybody tell me?
459.
That's the circuit number. I mean, I knew you could read the number, but What is that number for?
Oh,
The
oh,
circuit
that's-
number is 459.
459.
Now, look at this right here. If you've got your, you not notice this leg that comes off of here, it only goes to the ones that have that particular engine in them. All right, now there's your AC compressor clutch relay. All right, so look at your fuse here. Always go back and check your fuse before you do anything else. Here's another rule of thumb. When you're doing electrical work on one, if you're found out that there's not a, you might even trace your power on the schematic all the way down here. Go to the easy connectors to get to first. I'm always hammering on that. If it's easy to get to, go to that one first. All right, the fuse is easy to get to. Make sure the fuse hasn't been removed, because people will do that. They'll pull one from one place and put it somewhere else because their radio ain't working, and they'll jerk a fuse out. And if they don't notice anything that ain't working, then they'll say, well, it must be aight, But then they bring it to you because their cruise control won't work because they moved the darn fuse out of there. Okay. All right, so there's your, now watch this right here. You see this little, right here? That means that's coming from another page. And on another page, you're gonna see an arrow pointing down to there, and I think it may be on the previous page, I could have found that. And if you gotta find out where that's coming from. If that would give you an idea to track it. They couldn't put, you see that wire schematic right there? That is the entire wiring schematic for a 64 Chevrolet Biscayne. The whole thing. One end to the other.
Now that thing,
Ignition,
that's
all-
up to
everything. Yeah, and now, they've got, like on some of the cars, you'll have 3 or 4 books full of wiring schematics and stuff. But they draw them so that they can spread them across several pages. Now, this is the way it looks on a Ford. See how it looks slightly different? Now, some of the Fords, the newer Fords, are screwy looking and almost like they're drawn by a machine or something, kind of like the GM one and all. But then you're going to see something like this, and some of your Hondas has actually got schematics like this. I'm going to be showing you several different types of schematics here. And you notice the fuse is coming in from the top. You see a fuse symbol. You see this dotted line that's telling you that you're not seeing the whole fuse panel, you're just seeing that part of it. Your engine compartment fuse relay box, you're seeing just part of it, but you're seeing the entire relay. Solid line, you're seeing the whole thing. Dotted line, you're not seeing. All right, now, if you've got little dotted lines that are connecting these 3 wires, they're going through the same connector shell. I can't hammer on that enough. Sometimes I say that and people don't get it when I put it on a test. All right, your blower motor, look at this. The blower motor is hot all the time. You got that? So if my blower motor is not working, I'm going to look, see, the ground is actually fed through here. Now watch this. This right here, when that's off, see that? Now when I'm over here on max AC, excuse me, right here, panel, when I put it on panel, ground is available to this. And then my fan is actually going to feed it through these resistors. When I'm going through all 3 of them, it's low speed. When I'm going through